in the second half, the force we can write as minus k y I cap, because the y coordinate will continuously change, minus k, x coordinate will not change, ka j cap, and the displacement would be along y axis. So we can, at any time when the displacement is y, at any intermediary stage when it has reached to a coordinate, let's say that is a comma y, at that point the displacement has been from 0 to y. So at that intermediary stage the displacement vector is y j cap, because we are just looking in the second part. So work would be force vector dot displacement vector. Now j cap into I cap would be 0, j cap into j cap would be 1. So work at any intermediary stage is minus ka into y, and when the whole process is completed, when the journey is completed and it has reached to a comma a, then the displacement will be total of a. So the total work done would be minus k a square. Fine, pretty simple, isn't it? Okay, so one last question. They asked it in 2009. This is a pulley mass system. The first one of the mass is 0.36 kg and the other is 0.72 kg. And you will assume the ideal situation in which the pulley is massless, the rope is massless, pulley has no friction as well. Now you have to find when the system has been let loose from that point to 1 second, the total amount of work done on this block of 0.36 kg. So we have to find work done on 0.6 kg from 0 to 1 second after the system has been set free. So again you'll have to try this on your own. Stop the video and solve this one out, and then we'll discuss. Okay, so we'll start the discussion. This problem can be solved very easily after we have studied work energy theorem, but since now we have not, and we'll very much like it to do without work energy theorem from the basic of the formula of work, which is force into displacement. It could be done, and that would be easy. So we'll try and find the answer. The work is force into displacement. So if you want to find the work on 0.6 kg, then we have to find the force on 0.36 kg. The force on 0.36 kg is the tension that is acting against the gravity. But the work done, internal force of the system is tension. So work done on 0.63 kg will be actually the work done, which has been done by this tension in pulling this up, because this tension is actually the force which will pull this up. This being lighter will go up, the heavier one will come down. So actually what we have to do is find the tension and find the displacement of this 0.36 kg mass in first second and multiply them. That will be the answer, because force is going to remain constant. So it will be a simple multiplication after we find both. So to find the tension, we just have to write simple Newton's law equation. Tension here would be upward, tension here would also be upward. We know tension is always away from the body. This mass, the heavier one, will come down. mg, that is 7.2, is acting downwards, minus t will be equal to mass into acceleration. The acceleration of both the masses will be the same, because spring will not get stretched it is unstretchable string. So by whatever amount this is going up, by the same amount this would come down. The acceleration of both the blocks will be the same. So this is the Newton's law equation for Newton's law for this block. For this one, tension is pulling it up. So T minus 3.6 will be equal to mass into acceleration. Now you got these two equations. We have to find tension. So we have to eliminate A. So we just multiply the second equation by 2. So we get from here 7.2 minus T is equal to 2T minus 7.2. This gives us 14.4 is equal to 3T. So T would come out from here as 4.8. So T is 4.8. Now so we got T. So we have got the force on this block. Now we have to find the displacement. Displacement can be found out from S is equal to ut plus half at square. Initial velocity is 0. We have to find acceleration to get displacement. To find acceleration, we should use F is equal to ma. Net force on this is 4.8 upwards, 3.6 downwards, and the mass is 0.36 into acceleration. So this is 1.2 is equal to 0.36 by A. A from here would come out to be 10 by 3. Okay. So once we have acceleration, we should have displacement. Displacement would be then half A T square. T square is 1. So displacement is 5 by 3. So now work done would be force into displacement. So our work done should come out as 4.8 into 5 by 3. This is 1.6 into 5. That is 8. 8 joule of work should be done on the lighter block from 0 to 1 second. Okay, so this is quite simple, and this kind of question is expected from you that you should be able to solve. So now what you have to do is you have to go to exercise number 1 on work, go through it, solve all the problems, spend some time working out them, and then actually move on for the further theory. Please go for exercise number 1, solve each and every question. There are not too many questions, but if you solve them, actually then you have this topic under your belt.